So example 8 here, another equation involving fractions, and it's really just written in a slightly different way, and you should be prepared to see an equation with the fractions written in front of the bracket. Now, just as an aside here, that first term could also be written as 2 lots of 2x plus 5 all over a 3. So that is the same as this first term, only the 2/3 has been kind of dragged out to the front, and it's just been written in front of the bracket instead. So don't panic if you see something like that. It just gets dealt with in the same sort of way now. This is 2 over 3, and on this fraction that's 1 over 5. We need to clear out these fractions, and the way to do that would be to multiply by the lowest common multiple of the denominators, which in this case is 15. So what we're going to do is multiply everything by 15, this term here, and the 3. 15 lots of 2/3. 15 times 2/3 is 30/3. So this becomes 30 over 3 lots of 2x plus 5. So I haven't got rid of the fraction yet, but maybe you can see the simplified that's going to come here. And then the same thing over here, we're multiplying by 15, remember. Let me just put this up here just to remind you. We're multiplying everything by 15, that lowest common multiple. And 15 lots of a fifth, well, that's going to be minus 15 over 5. Not doing too much in this step other than just bringing that multiplied by 15 in across every term. So that's both the left hand side and of course the right hand side. 15 lots of 3, 45 in here. And as we've seen in previous examples, this now opens up a bit of cancelling for us. This fraction can simplify down because both numerator and denominator divide by 3. So that's going to give us 10 over 1. And same thing over here, these both divide by 5, giving us 3 over 1. So writing this out a little clearer, we've now got 10 lots of 2x plus 5. The fraction's gone there, minus, and all that's left here is 3 lots of 4x plus 9, all of that equal to 45. So what we've done is multiplied both sides of the equation by 15. The consequences are that the numbers got a bit bigger over here, but the good thing is that the fractions have all disappeared, and we're left with something that we're a bit more familiar with. We can now multiply across this bracket, so 10 lots of 2x giving us 20x, and 10 lots of 5 giving us 50. Again, watching the signs here, that's negative 3 multiplied by 4x, so negative 12x. And negative 3 multiplied by positive 9 gives us negative 27. All of that's going to be equal to 45. Simplify, simplify it all the time. Let's see what we've got here. 20x take 12x, so that means we've got 8x, and 50 take 27. Well, that's a positive 23. All of that equal to 45. So now we've collected up the x's and the numbers, and we can get 8x on its own on the left hand side by subtracting 23 from both sides. That's 22, and then dividing both sides by 8 will give us 22 over 8. They don't stop there because that can be simplified. Both of these dividing by 2, numerator and denominator divide by 2, gives us 11 over 4. And again, as we've seen before, I think it's quite nice for us just to turn any improper fractions into a mixed number. So in this case, how many 4s are 11? There are 2 4s and 3 left over. Now, probably worth pointing out that if the question asks you to leave your answer as a mixed number, then obviously that's what you're supposed to do. If not, then 11 over 4 is perfectly acceptable as an answer. That's absolutely fine and totally correct. But what you can't leave is something like 22 over 8 because it can still be simplified. So as long as you're fully simplified, you can leave a top heavy fraction like this, an improper fraction, although it's quite nice just to take that extra step and turn it back into a mixed number.